Okay, this is a video on your eggshell lab. Now, eggshells, which are mainly composed of an ionic compound, an insoluble ionic compound known as calcium carbonate. Okay, so the whole purpose of this lab is to make it. Okay, and you're going to be making it through a precipitation reaction. Okay, now I'm going to go ahead and write the two reactants for this reaction, and I would like you to pause the video, write out the equation, balance it, make sure you include the states of matter, okay? That way we can be on the same page. If you're not on the proper equation, make sure you fix it when you're done, okay? Okay, so there you go. Sodium carbonate, calcium chloride. Go ahead and pause the video and write out the complete precipitation reaction, including states of matter. And then I'll show you the answer. Okay, this is what you should have. You should have sodium carbonate with calcium chloride is going to form calcium carbonate, which is a solid, and 2 moles of sodium chloride, right, or at least the molar ratio there. All right, so there's my equation. Now, from this, if we were able to do a limited reactant lab, which is what we're doing, right, if I have a mass of this and I have a mass of this, I should be able to determine a theoretical yield for my calcium carbonate, okay? Hopefully it's important that we understand that we could form a theoretical yield for the sodium chloride, but we're actually going to filter this out, right? You're going to mix two solutions, and then when those two solutions are mixed, you're going to then filter it through some filter paper, okay? And when it's filtered through the filter paper, so we'll have a little beaker here, right? And in the beaker there'll be a funnel, and inside the funnel you'll have a piece of filter paper, okay? And I'll show you how to do make your cone for your filter paper in class. But you're going to mix the two solutions, then you're going to pour it into the funnel. All of the water, which has sodium chloride in it, since sodium chloride is aqueous, is going to drip down, leaving only the solid calcium carbonate to be stuck inside the filter. Okay? And then you'll let the filter dry overnight, and then you'll get the mass the next day. Okay? Now, some important things to remember when you're doing this lab is on your filter paper, okay, before you do anything with the filter paper, all right, what you need to do is get an ink pen, a ballpoint ink pen, okay, don't get a felt tip. Roller balls don't work that well either. Get a ballpoint pen, okay, and I want you to write your period, so let's say period 2, right, period 2, and the initial, the first initial of everybody in your group. Okay, so let's say it's me, right? So Bill and Chuck, right? So I would write 2 P B C. Okay, that way I know whose filter paper this is, because we're going to set the filter paper over there, and we need to be able to identify whose is who. Also, you don't want to add something to your filter paper after you've masked it, okay? Because obviously if I'm going to find out what the mass of the calcium carbonate is, and the filter paper is where the calcium carbonate is supposed to be, right, when we filter it out, I want to get just the mass of the calcium carbonate. I don't want to get the mass of the calcium carbonate plus the ink that's on the filter paper, okay? So let's go ahead and go through kind of an overall procedure, all right? So one, you're going to have a known molarity of the calcium chloride. Right? Now, if you don't know what molarity is, make sure you go back and watch the molarity video. But you're going to have a known molarity of calcium chloride, and you're going to add, right, a specific amount of, in milliliters, specific amount of milliliters of the calcium chloride. That's what you'll use, okay? I'll tell you how much you're using, okay, because every period is going to use a different amount, all right? And you are also going to make a solution. So you're going to make a solution with the sodium carbonate, and it's going to be in a range of mass, right? It doesn't necessarily matter how much water you use because the water is going to be dripped down anyways, okay? So what I'll have right here with the sodium carbonate, I'm just gonna throw this number out there. It may be what we use, it may not be what we use. But let's say you're gonna use 0.5 to 1.5 grams of sodium carbonate. All you have to do is make a solution, which means you need to add enough water to dissolve it. Okay, again, you may not be using exactly, this range of sodium carbonate. You may not be using 0.5 to 1.5 grams. Okay, that may change. But how you make the solution doesn't change, right? You get your mass, whatever you are assigned, and then dissolve it in enough distilled water so it's no longer, out of solution. You want to make a complete solution, which means you should see no sodium carbonate powder. Okay, and then of course the third thing you're going to do is you're going to mix them. Okay, right? So you mix and swirl or stir, right? Whatever you happen to be doing. Okay, if you want a stir stick or a little coffee stir, I gladly will provide one for you, or you can just give a light swirl. You do not want to have a lot of of swirling action, because if you swirl too much and then it flies out of the beaker, then obviously you're going to be losing some of your product, and that's not what we want. Okay. Now, when you mix them, you should see a white, precipitate, okay, or a white solid forming. Okay, that is your calcium carbonate. Okay, so obviously you don't want to swirl it so hard that it flies out, because you're going to end up massing that. Okay, so I've made that, right? Or I'm going to label and mass my filter paper, right? And then I'm going to get a beaker and filter the mixture. Remember, the sodium chloride solution should drip down, and then that would trap the calcium carbonate in the filter. Now, you need to make sure you get all of the white solid out of the beaker. That means you have to add more water after you've poured it, and then pour the water through it, and dump it until all of the white's gone. That's what you need to do. Okay? There should be no white left. No white solid left when you're done adding it's the wrong place, I guess I should say, right? When you're filtering it, yeah, no white left in that beaker that you initially mixed them in, right? All of it needs to be out of that beaker. Okay, and then 6, you let it drip down. You're going to want to kind of know what you're doing in here, because the filtering can take a while, especially if you use a lot of water. So don't just don't overdo it with the water, because the more water you use, the longer it's going to take to filter, which means if it takes a long time to filter, you're going to be sitting there doing a lot of stuff, or sitting there doing nothing, waiting for it to filter. Now, while you are waiting for it to filter, you should determine a couple things. One, you should determine the mass of calcium chloride that you had in that known molarity of solution, right? Because if you have the molarity and you have the volume, you should be able to give me the mass, right? And you should also be able to determine the mass. Well, you don't have to determine the mass at all, because you know exactly how much mass you had of the sodium carbonate, right? So if I know the mass of sodium carbonate and I know the mass of calcium chloride, okay, I should be able to determine a theoretical yield of the calcium carbonate. Okay. Now, remember, you need to use the balanced chemical equation and determine which one is the limiting reactant. Okay, you can't just pick one of them and then, oh, that's how much calcium carbonate I'm going to make. Okay, because that could really throw you off when it comes to your percent yield at the end of the lab. Because the end of the lab is the next day you mass your solid and you find out if your actual yield was close to your theoretical yield, right? And then obviously you're finding out how close it was by calculating a percent yield. Okay, so your lab report for this, okay, which before you get overwhelmed on the procedure I just went over. You are going to have a lab paper, and you are going to have the procedure written out for you. It's just nice to know what you're doing when you're getting in here, okay? But going back, your lab report. Your lab report is going to consist of, let's go, 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. With 1, you're going to do all. Okay. 2, you're going to do A and B only. 3, which is your data tables, all. Okay. 4 is a graph. You're not going to have a graph. Okay, so don't worry about it. Okay. 5, you're going to, it's a calculation. So you're going to do the calculation. Okay. So do it. Obviously, I'm talking about all calculations here, right? The calculation of determining the mass of the calcium chloride that was in that known molarity of solution. The calculation of the theoretical yield, right? Meaning you need to show the linear reactant problem and show both reactants to find out, well, how much sodium chloride, how much calcium carbonate can I make? Okay, so you should have a linear reactant, or sorry, a molarity calculation and a linear reactant calculation. Okay. Also, number 6, you're going to have A, B, and C. Okay. Now, I am going to add a couple things for this. Not so much for the lab report, but for this lab, it'll just be on your unit review sheet. Okay, so you'll have your unit review sheet. There are going to be some questions on there that deal with the lab. Okay, then you can't do that quite yet. Okay, so this is your protocol for your lab. Now, everybody's favorite thing, there is only 1 per group, right? 1 per group. So I only need 1 lab report per group. But of course, you understand what goes along with that. We're going to have a presentation. Okay? The day the lab report is due is the day you're going to present. Okay? Now, everyone in the group, okay, every group's only 2 or 3 people, but everyone in the group is going to talk in some way, shape, or form. Okay? So, and the presentation doesn't be long. I mean, we're talking like 2-3 minutes at the very most. Okay? Probably many of you can get it done in under 2. Okay? But there will be a presentation on this lab, so everybody better make sure they know what they're talking about. Okay? If you guys have any questions about the lab, be sure to ask. If you have any questions about like calculating molarity, okay, or calculating theoretical yield, make sure you go back and you watch the videos on those 2 topics.